Okay, so we've learned how to do the fundamental theorem of calculus. I used the little song, but shortcut, integral from a to the b, say, hey, of our f of x is the integral of b less the integral of a. So our first step, I'm gonna do these here a little bit easier maybe, but just so you have some extra examples, and then I'm gonna show you the full thing all the way through the calculator so you can check. First step is to integrate. And so 1/4 x to the fourth plus, I'm going to raise that to the third, divide it by 3. So this is 2/3 x cubed. So my notation is like this. My integral, I'm going to put the b up here, the a down here. So I'm going to plug in 1/4 times 2 to the fourth plus 2/3 times 2 to the fourth minus, where all the mistakes happen is at the minus, 1/4 times negative 2 to the fourth. So that's going to be positive. Don't trust your calculator. Trust your senses there if you put parentheses. Plus 2/3. Oh, don't trust anything. That should be a 3. 2/3 negative 2 to the third. Okay, double checking all your work. 2 to the fourth, 2 to the third, negative 2 to the fourth, negative 2 to the third. And then it's a matter of just cleaning all that up. Okay, so whatever you get for your answer, you can always verify on your calculator. Put the function in the y equals and either graph and go to calculate the integral, lower limit negative 2, entering it in. I'm not using the cursor. Upper limit 2 and 10 2/3. The other place you verify it is on the screen. Math function int. And this calculator has the shortcut, so negative 2 to 2. Again, your y1, if you want to re-enter the whole function there, go ahead. Knock yourself out. I don't want to do that. I want to waste that time. Okay, if your calculator does not have this shortcut, then it's going to say function int, and you're going to enter the same thing that's there. y1 x, that means we're taking the integral with respect to x, and then negative 2 to 2. So the things match up. Negative 2, 2, there's your y, there's your x. So even if you have the other method. Okay? Okay, the second one, and this came up in the practice quiz yesterday. Do we have a quotient rule for integrals? No. So some people thought they were done with this one. Well, we have 3 strategies for integrals. Multiply everything out till you get a polynomial. Write rationals as exponents, or divide monomial denominators so we can change the form. So I'm going to first change the form of this by dividing both of these by x squared. And this is how it looks. Some of you will show that step so you understand it. Other people that already understand that step, you don't need to show that step, but that's where it comes from. Before it was a single fraction, it was 2 fractions with the same denominator. This only works with a monomial denominator. Okay, so I rewrite. Now I have 4 plus 4x to the negative 2. Once it's a polynomial, you can use your polynomial rules. Integral of 4 is 4x. Integral of 4x to the negative 2, add 1 and divide by negative 1. Can you check it to see if it works? The derivative is 4x to the negative 2. Good place to stop and check is right there. 4 times 3 minus 4 over 3. X to the negative 1 means denominator. Minus 4 times 1 minus 4 over 1. So 12 minus 4 thirds minus 4 plus 4. That is going to give us 0. So 36 thirds minus 4 thirds equals 32 thirds. Now let's verify. So if we go here, change what's in there. You can put the original back in. So 4x squared plus 4 over x squared. So if you put the original in, that will also allow for catching of any algebra file you may be made there. And we want to calculate the integral. Lower limit is 1. Upper limit 3. Shades underneath it. Also 10 and 2/3. I promise you that I actually took this one off the warm-up and randomly took this one out of the book. We got the same answer for both. That is not a coincidence, but it is a Goocher. If you don't know what a Goocher is, you probably need to watch Stand By Me and listen to when the Goocher happens, when they're flipping coins. Vern talks about the Goocher. I'll have to show you a picture of Vern sometime. That's it.